still working on your self-assessment. You will have time to turn that in before you leave, so don't feel like you have to get done right now. You haven't quite finished yet. Alright. We're probably just going to get through example 1 here. At least get us a little bit introduced to the law of sines here. And then I think we'll call it good for notes today.
Which do you prefer, the law of cosines or the law of...
Depends on what you're given.
I totally prefer the law of sines. Is there a law of tangents?
Sometimes you can't use the law of sines because you're not given enough information. Sometimes you can't use the law of cosines.
Is there a law of tangents?
No.
Yeah.
Alright, we're going to show the proof of where the law of sines comes from. It does come from the area formula that we just learned on the last section, which is 1/2 BC sine A. Now, if we were to write 1/2 BC sine A, knowing that represents the area of a triangle, would the area of the same triangle be 1/2 CA sine B? Yeah, the two sides and the included angle. Yeah. Okay. And then the third way I could write the same area formula would be B. What? BA or AB sine C. Okay, so all three of these represent the area of the same triangle, just written 3 different ways. Now, if I was to divide that whole expression, whole chain of equations there, by ABC.
Yes. You would get cosine over sine. Sine A over A equals sine C over C.
Well, actually, 1/2, I'm going to do this too.
Half.
Okay, so in this first one,
It'll just be sine. 1/2 of sine.
and all of them, the 1/2 will cancel, right?
Yep.
Okay, in the first one, sine A will stay, and then what will be left on the bottom? A, right? Because the BC and the BC here would cancel, leaving you with A on the bottom. So the first part of the law of sines is sine A over A is equal to, and then the last, or the next piece there, the 1/2 would cancel, the C and the A would cancel, leaving you with
Sine B over B.
Sine B over B.
Why are we putting it over ABC?
To show, I mean,
This is the proof.
This is the proof to show where the law of sines comes from.
But
You don't need to understand it.
yes, I do. Actually.
But what?
Like where does like what is the point of putting it there? Just to prove the proof?
Just to show the proof.
The whole point is
To show where it comes from. Just like when we did the law, of cosines, we used the distance formula.
That's basically simplifying.
Yeah.
Okay.
You're not actually going to be using this in a problem.
No.
It's ridiculous.
Oh wait, it's since all of those are equal to each other, you're just doing.
Pulling out a greatest common function.
Okay.
Basically, all it comes down to is you're just gonna have sine left. It's ridiculosity.
What?
Sine equals sine equals sine.
No, actually.
Okay.
Sine A over A was our first fraction, right? Sine B over B was our second fraction. And then sine C over
But you can't put A.
C.
Because A is
Sine A over A.
sine A over A. It has to be sine of angle A.
It doesn't matter that much.
Yes.
All of them lowercase. Think about it. Yep.
Yeah.
Wow. In the grand scheme of life.
What?
It's not important.
Okay, now the reason you have all 3 is not because when you're using the law of sines you have to use all 3, but it does depend on the information you're given. You could set those equal to each other and solve for some stuff. You could set those equal to each other and solve for some stuff. Or you could set those equal to each other and solve for some stuff. Because you're saying that all 3 of these are equivalent to each other, but we only ever use 2 fractions. What? Depending on what you have. Okay, so in triangle ABC.
Did you say a very fallen?
Bog. That's what he said.
I typed a very fallen.
Yes. And that's an argument something coming in there, right?
Shh. again, as I was saying before, when you use the law of sines, you never use three fractions. You just pick the two fractions that have the information that you're given, and then go from there.
So we set them equal to each other?
Yeah. For example, example 1, you're going to be given a triangle, ABC. B is going to be 64 degrees. C is going to be 38 degrees. And side B is 9 feet. Find A and C. So I'm looking for what information here? Angles or sides? Sides. Okay, so I'm going to draw a triangle. A, B, C. 38 degrees here, 64 degrees here, and this side is 9 feet. Hello? Hey. Okay, I'll send with that. Thanks, bye. Alright.
Was that for me?
Nope. Alright. So what you have to look at in this problem is the information you're given. You're given the most information about what angle and side. Or what pair? B. So that would be a good place to start, is to set up that ratio, that sine B over B, and we're going to plug stuff in here in a minute, but we're at least deciding what two fractions we're going to use. So sine B over B, and we're looking for side C. Now why would I want to start with side C?
Because you have the angle.
Because I have the angle for side C. Now, would it be that difficult to find the angle for angle A? No, because all angles in a triangle add up to 180. Okay. But we're going to, since we're given angle C, we're going to start with that at least. So we're going to set this equal to sine of C over side C. Now, with the law of sines, you can only use the law of sines if you have three pieces of information and you're missing the fourth piece. You have to have at least two angles and one side, or one angle and two sides.
But
So
you don't have either side because
You have B.
I have B. I don't have C though.
You don't have the side of B.
oh, I put 9 feet there.
Good start. Wow.
So we're going to plug in this information where it goes.
Someone's late.
We don't need a comma. Okay, now algebra work here. When you have two fractions set equal to each other, you can solve that by cross multiplying. You can only cross multiply when you have an equal sign set in between two fractions.
You can cross multiply and bind, right? That's what how I told you.
Yes.
Yeah.
So we're going to cross multiply. And so C times sine of 64 degrees is going to equal 9 times sine of 38. And so C will equal 9 sine of 38 divided by sine of 64. Now, if we go ahead and punch that out, I usually do the top first and hit enter, and then divide it. You should get 6.165. Does somebody else get the same thing?
TJ did. He's over here celebrating.
What? 6.164.
Okay. So we have C equals 6.165 feet, or 4 if you want to truncate.
Oh, I know what I did wrong. I divided by 64 instead of sine.
Okay. Then the next piece that you do, once you find C, then you might, well, in this case we had to find side A as well, so you have to set up another ratio. I would stick with the first fraction, since you don't have a decimal for this side. So you have sine of 64 over 9. And then you're looking at sine of, what is that angle? Or how would I figure it out?
78 degrees.
78, because we said everything has to add up to 180. So if you take 180 and subtract the other two, you end up getting 78. So this would be sine of 78 over A. And then isn't it just doing the same thing? Cross multiplying? So you get 9 sine of 78 equals A sine of 64. And then it's just punching it out. So 9 sine 78 divided by sine of 64. End up getting 9.794, or 5 if you round up.
For the
Feet.
log sines, you need two angles and a side, but for the log cosines, you need two sides and an angle.
I'm surprised that I actually put 75.
Yeah. You can use the law of cosines when you have two angles and a side, but it becomes a little more complicated. Same thing with log sines if you have one.
It's just easier.
Yeah, that's why we have two choices. So if you're given a choice,
Okay, I just need to know, like,
what the difference is.
cool. Well, that's
Not too shabby, right?
Wait, what?
Not too shabby.
Where did
Alright.
the word shabby?
I don't know.
What does that even mean?
I don't know.
What's it sound like?
Shabby. It sounds like scabby. It makes me think of scab. Ew.
That's kind of gross, actually.
It's like hair and scabs at the same time.
Hey, why would you think of hair?
Alright, on that note,
Wait, a pear?
go to example 2. I want you to do this one before you leave, using log signs.
Jaws, nice.
cool. I'm sure I
I did
finished
these
it
all
this
from
morning.
John Clark.
Good job, Donnie.
I didn't get it.
Doing example 2.
In the movie Jaws, J equals 48 degrees.
Find the shape of Jaws' fin. Is that it?
Nope.
Oh.
But okay, the shark's name comes from Jaws.
I've never seen the movie. I haven't either.
I don't even know it as Jaws.
If I need to, I'll make sure that you show that to me before you actually get to leave today. So hopefully you're working as you're talking.
Sorry. I'll shut up now. Well, I'm sorry. Yeah, I know. I skipped Colt for you. JW.
double check as you're working.
Crap.
You should end up getting those two values
Oh wait.
for W and J.
Thank you for the answers.
Wow,
Label
TJ.
it. You didn't label it.
Wait a second, I already
There's
had
nothing to
the
label
answers.
it.
Oh, there isn't. It's just you never actually.
There is no unit.
Oh,
Thanks for giving me
okay.
the answer.
Yeah.
I don't know.
So
Oh wait.
Whoa.
Miss Cross, do you
Yeah.
realize that it's still recording? I think.
Yeah.
Miss Cross, do you realize that your mom?
That's funny.
Never mind.
Blasphemy.
You know what, she said, I say,
I was
the
wrong.
answer, she looks at me and I'm like, whoa, wait. I already have the answer.
Make sure that I have your self-assessment before you leave, and we've written down the homework for tonight.
Man, I got all that.
6 problems. Should take you very long. 2 area problems, 2 cosine, log cosine problems, and then 2 log sines.
No. Calm
So
down. Whiny.
I'm feeling no homework over
Whoa.
here. I got the Yale.
Whoa.
Well, I'm hoping to give you just a couple
I
problems.
complain enough for the whole class.
So I got to Yale yesterday.
My meeting.
So I got into Yale. Birthday?
Yeah.
Supposed to be?
Yeah,
Aw.
they come knocking. Whatever.
I'm sorry. I think I'll be flying to Canada. Next thing I know, I'm gonna need a wheelchair.
Somebody's
bragging.
I'm just kidding.
Look out.
Congratulations then.
What was it, Ian?
All your success and
All
hard
you
work.
students, please come to the high school office. Randy Rowe, Jacob Wounded,
Congratulations on your success, but
and
more
Travis
congratulations on
Dowell.
your
The following
failure.
students will be enlightened.
Whoa.
Adam Billier, Christine
What
Billier,
happened?
Matt Kalsreiter,
Oh,
Matt
sorry.
Shapiro, William Heil,
I did not
Will
hear that
Pratt,
burn.
Kim
Do
Smith,
you have to,
Tara
do you have
Danhuzer,
packages in your
Sam Walker, and
Okay.
Lucas Rotberg.
Why don't you go get your
And
stuff and
finally,
come back?
the following
'Cause I gotta
students
find
will
it.
be dismissed as they
All this food. What are you gonna do?
Eat it all.
Megan
it's
Kohlring,
so,
Abby
like,
Price, Rachel Parkhurst,
overwhelming.
and Alexander.
Oh wait, it's still recording.